Thanks. Today we will visit the hydraulics lab. Here you know that hydraulics means hydro means water. If you want to study the flow characteristics and flow properties of water, you have to conduct the various tests on the water. Here, first we discuss about this notch apparatus in order to measure the quantity of the discharge. Here in canals, usually by constructing the dam across the river, the water is allowed to flow to the different types of canals. Here, in order to measure the discharge or quantity of the water, this instrument is used. Here, this one is the model of the rectangular notch. The different types of notches are available. It may be triangular notch, rectangular notch. Here, by using this, you can measure the quantity of the discharge. This model of the canal. Here, you can measure the discharge or quantity of the water in cubic meter per second. Here, this one is the centrifugal pump. In order to find the efficiency of this centrifugal pump, here this is the setup. These are all the models. Here, this one is the sump tank. Through this, we can lift the water. Here, it is provided with the motor. By operating the motor, we can lift the water and we can allow the water to collect in the collecting tank, and we can measure. This one is the piezometric head. We can measure the head of water, and then we can measure the. Here, this one is the meter. Here, we can measure the speed in RPM. Here, this one is the head of mercury. Here, this one is suction head, and this one is delivery pressure. You can find the efficiency of this. RFIC is a small piece of a rectangular or circular opening provided at the bottom of this collecting tank. This one is the sump tank. Here also the apparatus is used to find the discharge. Here the coefficient of discharge we can calculate the theoretical discharge as well as the actual discharge, and then we can find out the coefficient of discharge. Here the flow of water, that is head of water, we can measure with the help of this graduated scale, and we can collect the water by observing through this collecting tank provided with the piezometric head. Here we can measure the surface area of this and the time required to collect the water up to a known head of water, and then we can measure the actual discharge and the theoretical discharge by using this. Here this one is the tank. Here we can make the head constant, and then we can allow the water, we can lift the water through this sump tank by operating this motor, and we can lift it and we can allow the water to flow for different head of water, constant head of water in the overhead tank. We can measure the discharge, theoretical discharge as well as actual discharge. Then we are able to calculate the coefficient of discharge. Here this one is Venturi meter. Here it is working on the principle of the Bernoulli's theorem. It states that the Bernoulli's theorem, the head remains constant at all the positions, but here by observing this one is the Venturi meter. Here this one is converging, and the head is here. There is a reduction of the diameter of the pipe, and gradually the diameter increases. This one is Venturi meter apparatus or setup. Here also it is provided with motor and sump tank. Here the aim of this experiment is to again the coefficient of discharge. Here by allowing the water to flow through the Venturi meter, we can collect the water and we can measure the time as well as the head of water collected in this collecting tank, and we can measure the actual discharge, and then the difference in head. Here while moving the water from one end to the other end, there will be a small decrease in head of water pressure. Here we can measure. It is provided with the U2 manometer. By using this, the difference in the the head between the inlet and the outlet. You can measure the difference in head by using the mercury U2 manometer. By using this, we can calculate the actual theoretical discharge. Then you can measure the actual discharge by collecting a known quantity of water. Then by using the apparatus, we can measure the quantity of the discharge. Here, this one is the verification of the Bernoulli's theorem. Bernoulli's theorem. The head remains constant by continuity equation. Here, it is provided with the venturi meter. Here, at various points we can measure the difference in head. The head remains same at every point. That is by Bernoulli's theorem. But here there is, because of the flow, there is a difference in head. That we have to verify whether there is a loss of head from one point to another point. That we can verify by using this Bernoulli's apparatus. And then here this one is venturi flume. Here this one is venturi flume, and this one is also measure. We can measure the discharge of water. Here this one is the canal model. Here this is a pump. It is provided with a pump. We can lift the water by using the pump, and we can operate. We can allow the water to flow, and we can measure the discharge, and finally we can find the coefficient of discharge. This one is the impact of jet on vane. We can provide the different types of vanes. Here it is fitted with a motor. We can allow the water to flow, and it will hit the vanes. Here this one is provided with the vane. Here we can operate this, and we can measure the. Here it is provided with head off to measure the head. Here this one is the jet pressure. By increasing or decreasing, we can measure the head off or pressure, and then here we can observe. This is digital indicator. It is provided digital indicator. By using this, we can measure the jet force which will hit the different types of vanes. Here this one is the Pelton wind turbine. Turbine is, here you have observed in the production of electricity. Here, in order to find the efficiency of the turbine, here this one is the Pelton wind turbine. Here this one is Pelton wind turbine. Here the water, we can allow the water to hit the blades. Here we can measure the efficiency of this instrument by using the Pelton wind turbine. Here it is provided with the rods. Here this one is the rod. We can maintain we can change the head, or we can operate this by using this wheel. We can operate we can allow the water to hit with different pressures. Here this one is venturi inlet. This one is head of the turbine. This one is the throat. Here this one is provided with a venturi meter. Here also we can use the same principle of Bernoulli's theorem. Here it is provided with a motor. We can lift the water by allowing this motor to lift the water, and we can allow the water, and water is allowed to hit, and then we can find the efficiency of this turbine. Similar to this one is Kaplan turbine. Here also the procedure is same. Here we can allow the water. Here it is provided with the blades. This one is the blade. We can lift the water. Here only the difference is, here it is provided with, there it is provided with the venturi meter, but here it is provided with the RFIS meter. Here this one is here we can operate this. Here we can apply the load. Here it is provided with the different bulbs of different capacity. We can operate the bulb, we can apply the load by using either the loading switches. Here this is the head of the turbine, head of water in the turbine. Here this one is the generated current. Here this one is the generated voltage. In order to find efficiency, we have to measure all these things. And then this one is speed of the turbine. By using this digital indicator, we can operate. We can measure the speed in RPM. Then this one is here in the design of the water supply schemes. Water supply scheme, we can first the civil engineer is to identify the source of water. It may be surface water or it may be subsurface water. And then after treating it to the required limit, we can store the water in the storage tank. Treated water, we have to store it in storage tank. After that, we have to supply to the consumers doorstep with sufficient pressure. It should be potable drinking water. We have to supply with sufficient pressure. While moving from the storage reservoir or collecting tank, that is treated water, which we can store it in the storage tank. While moving from one end to the other end, there will be a difference in height. The pressure will get decreased because of the different types of pipes are provided here. This one is the PVC pipe of 1 inch diameter. This one is the GI pipe of 1 inch diameter. This one is 3/4 of an inch diameter. This one is 1/2 inch pipe of diameter. Here it is provided with the different types of taps. Different taps. This is for the tap provided for inlet, and this is the tap provided for outlet. Here the length of this pipe from inlet to outlet, that is 1300 millimeter. We can operate this valve, and remaining valve we have to close, and we can allow the water to flow in different types of or different diameters of pipe. Here this one is already I told that this one is PVC pipe and this one is GI pipe. Here these three are the GI pipes. Here while moving from one end to the other end, I told that the pressure will get decreased because of the surface area. Here the friction, there is a resistance against the direction, against the flow of water. Against the flow of water, there will be a resistance against the movement of water. Here we can measure the actual discharge. Here it is provided with the piezometer. We can collect the water to a known height and we can measure the surface area. Surface area multiplied by the rise of water up to a known time or up to known height. We can collect the water and we can measure the height as well as the corresponding time taken to collect the water, and then we can calculate the actual discharge. Here this one is provided with some time. Here we can compare the different types of pipes, in which pipe the pressure is more. Similarly, here this one is the major loss. The major losses is due to the friction. That is, the pressure will get decreased from the source of water to the consumer's doorsteps. Here, this one is another type of loss. That is because of the different fittings. Here, while going from one end to the other end, it is provided with different types of valves or different types of elbows. Here, this one is the reducer. Here, this one is unlocked. Here, there is sudden increase in the diameter of the pipe. Here, it is provided with the elbow bend. Here, it is provided with the bend. Here, this one is provided with the coupling. Here, in order to measure the loss of head due to these fittings, this is known as the loss of head due to fitting. Here, these are the minor losses. Here also, the procedure is same. By allowing the water to flow, we can allow the water and allow the water to flow from the inlet to outlet, and then we can collect the water. We can measure the actual discharge. Then we can measure head difference in head between the inlet and outlet to measure the quantity, and then we can find out the different types of losses that are available in the pipeline that we can measure, and we can estimate how much quantity of the water is available to the consumer's doorstep. Here these two are, one is major loss and the one is minor loss. By saying these few words, I will conclude. Thanks. Today we will visit the hydraulics lab. Here you know that hydraulics means, hydro means water. If you want to study the flow characteristics and flow properties of water, you have to conduct the various tests on the water. Here, first we will discuss about this notch apparatus in order to measure the quantity of the discharge. Here in canals, usually by constructing the dam across the river, the water is allowed to flow to the different types of canals. Here, in order to measure the discharge or quantity of the water, this instrument is used. Here, this one is the model of the rectangular notch. The different types of notches are available. It could be triangular notch, rectangular notch. Here, by using this, you can measure the quantity of the discharge. This model of the canal. Here, you can measure the discharge or quantity of the water in cubic meter per second. Here, this one is the centrifugal pump. In order to find the efficiency of this centrifugal pump, here this is the setup. These are all the models. Here, this one is the sump tank. Through this, we can lift the water. Here, it is provided with the motor. By operating the motor, we can lift the water and we can allow the water to collect in the collecting tank, and we can measure. This one is the prismatic head. We can measure the head of water, and then we can measure the. Here, this one is the meter. Here we can measure the speed in RPM. Here, this one is the head of mercury. Here, this one is suction head, and this one is delivery pressure. You can find the efficiency of this